The sliding filament theory is that muscle movement is generated by meiosis pulling on actin so that neither of the fibers actually shorten while whole sarcomere shortens.
A muscle contraction begins with a cross bridge where the myosin head is attached to the actin. The ADP and inorganic phosphate bound to the myosin head detaches, which causes the whole cross bridge or myosin head to pull on the actin, causing a muscle contraction. Then, an ATP attaches to the myosin head, causing it to detach from the actin. ATP is necessary for the myosin head to detach from the actin. Therefore, rigor mortis occurs because in death you don't make any ATP. Therefore, your myosin heads do not disengage from the actin, so your muscles become permanently contracted for about 3 hours. When the ATP hydrolyzes back into ADP and inorganic phosphate, the myosin returns to the cock position, ready for another muscle contraction.
An action potential travels down the axon to the axon terminal, where it releases neurotransmitters into the neuromuscular junction. The neurotransmitters then bind to ACH receptors, sending an electrical impulse down the T-tubule, which triggers the release of calcium ions into the sarcomere.
The myosin heads cannot engage with the actin because there is a tropomyosin protein in the way, shown in purple. A calcium ion must first bind with the troponin, shown in red, causing the tropomyosin to move so the actin binding sites, shown in blue, can be exposed.